Delta T.
All right, Q equals MC.
Wait, what is this for?
Number 1.
Oh, but
I just wrote it in an open spot. All right, and I can't remember. Is it a big Q or a little Q? Okay. Some years it was a big Q, so I can't keep track. All right, so we're looking for which letter?
Q.
We're looking for Q. All right, so what's the mass?
15.2.
15.2. And what are these numbers?
That's a change in temperature.
Change in temperature. All right, so when you use those, all right, what are you going to get?
I got 37.
All right, so 73.8 subtract 35.1. I got 38.7.
Okay.
All right, now I can't remember who said this. It might have been Madison. All right, she said we're missing Q and CP. So can you be missing 2 values in the equation? No. So you have to look on your orange sheet to find the missing value. So are you looking up Q, which is heat, or are you looking up CP on your orange sheet? CP stands for specific heat. Specific heat is on the orange sheet.
Interruption, teachers. You should have gotten an email from Mr. Johnson to cast your ballot for Teacher of the Year. That voting needs to be completed by 4:30 at the latest today. If you did not receive this electronic form from Mr. Johnson, please see Mr. Johnson in person to receive a paper ballot. Thank you.
All right, so when you look at the question, all right, copper is the element. So look on your orange sheet, find copper specific heat. What is it, 0.385?
Yes.
All right, 0.385. And then when you calculate Q, what do you get?
226.
226.
Because 3 significant digits.
Because of 3 significant digits. And what unit did you put on it? J for joules. Okay, should have a joule on it. Any questions about that?
You remember that?
Yeah.
Yes.
Did we ever get our grades on that?
Probably. I mean, I didn't count the grades.
What are you talking about?
I don't know.
You said
Assessment.
I don't even remember what I did.
assessment.
I think we handed it back out.
You
handed it back out. Yeah, we went over it.
What are you outside the bell?
Did I take them up?
Yep.
I don't remember taking them up. I thought I gave them up.
Yeah, we have.
Oh, it's stupid. So I don't think I have them.
We have them. I forgot to me.
I don't remember taking them out.
It's a CFA?
Yeah.
Yeah, I still have it.
Yeah, I was thinking on it because it was the stuff that was on the test before we took that test.
I don't even know what you're
Yeah. All right, so number 2. How are we going to find volume? What formula had volume in it?
Density equals mass over volume.
Density equals mass over volume. All right. So if density equals mass over volume, we have a what right here? So mass is 45.7. I asked you to find volume. We have no density. Again, where do we find density? Find it on the orange sheet. And I gave you gold. Gold's density is what? 19.3?
Yeah.
All right. Cross multiply. 19.3V equals 45.7. Divide 19.3 on both sides. So volume will equal what when you divide that?
Let me calculate it, but no.
2.3?
Yes.
2.3, what's the number I had behind that? 6?
Yeah.
And then looking at our units was grams here. On your reference table, it was what? Grams over milliliters or grams over centimeters cubed?
Grams over centimeters.
So it'll be centimeters cubed for our unit because the grams will cancel out.
All right, now I think I know number 3. Wait.
What animal did number 3?
No, it's a fake.
I did. I don't know.
Oh, no, go down. No.
All right, so we're okay with 1 and 2 now.
Yeah.
All right, so number 3. How do we find protons? What tells protons? Atomic number is protons. How many protons do we have? 33.
See? I did it.
How many electrons do we have? 33. What does this right here mean? Minus 5, which would give us what?
28.
28. Because plus 5 means we lost 5 electrons. Okay, we lost 5. All right, and then for the neutrons, how do we find neutrons?
76 minus 33.
76 minus 33 is
43.
43.
Okay, that was the part that I forgot how to do because, yeah, I put
Questions?
76 and it wasn't adding up. Yeah.
All right, questions?
No, ma'am.
Feel okay about that?
Yeah, I guess. No.
Yes, no?
Yeah, it's okay though.
Yeah, but she didn't.
Because my brain's.
Let's go over the test.
All right.
I did the best on this test that I've done on any test, and I was really
Me too.
surprised.
I was so proud of myself.
I did all right. I
Really
did
proud.
okay. I got an 8.9. It's like you get 7 degrees between all of my tests. No, it's not.
It's worth it. Like, you just have to get over like the first 3
Okay. What part? This test may have been the lowest.
It's a really good.
It's the lowest.
You just feel like,
but we're fine.
but don't like go home and like take a hot shower, like put it in your bed for a little bit.
Good job, Madison.
I picked that up last year. I'm a score.
It's so good. Let me see it.
What do you have to?
Okay.
Where's the shirt that was lost? That's put 19.
Oh, yeah.
No, you got the one about Rombo.
It was me.
No, it wasn't right.
And then
Wow.
for significant digits, really?
You know what?
One thing.
It's, I'm improving. So, you know what? I got one question fully.
Are you for real? I tried to put 2 up there the first time and I couldn't get it right.
What?
Oh my god.
This makes no
And that's the only one I missed. And look how easy it was to know.
That's bugging.
I tried to. Why do I always try this?
I make so simple mistakes that really upsets me.
What'd you
get? Probably like a 90.
Allie, Noah, Tree, Kira, Karen, Jessica.
I missed the whole ratio one because I didn't pay attention. I feel like
I have, you had to use it, now you're gonna go crazy.
I got a whole 87.
For the day.
I really don't
You had to use it again.
Bro, how do
What about right now?
I put, what?
Swall, maybe I'm wrong.
I don't know.
How come you get this count that wrong?
Because you, it says a synthesis. And you put, that was just rude.
Yeah,
One for like March.
Is it because of like significant or because I
That
added
is crazy.
Is it because I missed the significant digit or like is it because I added one more down? So
I got one.
Got one?
Oh,
Oh my god. I'm whacked. I could have had it.
I'm improving.
10 out of 10.
I don't even know what you did this question. Well, I was like, oh, these are numbers. Where you got the numbers? I don't know what you were doing.
Miss
I'm
Wall,
not
Wow, that makes me really
when you
sad.
grade my tests, are you like the boy that you can't grade with a straight face, and you can't grade mine with a straight face?
Yeah.
What was?
I didn't laugh when I graded it this way.
Because like what happens is math, I never know like the next step. Or the last one, there's a step from the wrong and it you put what? 7 times 4.
I'm just from the balances. And I tried to.
Everybody was
counted it
counting
wrong.
No, I got 2 whole questions.
I tried to at first, and I freaking counted everything wrong.
It's because at first I didn't.
Wait, I have a question
Yes.
I went to the I went back to whatever else kind of that's what. Make sure I get it right.
0, 1.
Sometimes I don't know.
You can see how much I erased. You can see how much I erased on 5.
And the one right below. For some reason, I kept writing 500.
Take this back entirely. And you just what she do double D.
Yeah, it's supposed to be out of Anybody else before I take it back?
I have a question.
Yeah.
I mean, everything else.
You can see how much I erased everything.
Anything circled is a total for a page.
Oh, you great. Go 12.
I got number
Because you
4.
can't change compounds in grand small. That's the normal ratio.
Oh, I was like, how did I get minus 11 on one question?
That's right. And the moles of
Hey, which
NGO.
one of y'all got number 5 right? Y'all are up with that. Wait, was it number 5?
Many people got number 5 right. There are 14 A's in the room.
How stupid am I? Oh my God. Great, sorry, right.
How stupid am I doing?
I gave you back a quiz instead of reaction. I gave it back so y'all would know. People still got it wrong.
Yeah, I wasn't paying that attention. I said, well, I read mole ratio, and I was like, okay.
Then I even gave you false credits. Alright, let me have the test back so we can move on. Now, the next test will most likely fall in the next quarter. So this is probably your last test grade this quarter.
Yay.
Okay?
Hey, no, what about the lab?
The last goes on this quarter.
Okay, good.
I'm talking about test grades. Alright?
Lab is a test grade though, basically.
It's not a test grade.
It's like.
It counts more than quizzes, yes. But it is not a test grade.
You shouldn't. Hey,
It is not a test grade. Does not count as a test.
if we all vote.
We do not vote. It's not a democracy. It's a dictatorship, in case you haven't figured that out yet.
Oh, that's not good.
That's what my dad said. This isn't a democracy, this is a dictatorship.
Now, if you have missing work, I will be here Monday, Wednesday, and Thursday next week, and that may be the last days you have before the end of the quarter. So if you have something missing, you need to get it made up. Particularly if you're like Chris back there who has a missing test. And I don't know who else has a missing test, but I think there's somebody else. Well, the quizzes aren't hurting you nearly as much as that test. Alright? Test grades are huge in your average. Even if you think you're going to do terrible on it, alright, you're probably, A, not going to do terrible on it. But secondly, even if you make a 50 is a whole,
Brings your grade up.
it brings your grade up.
Where? It does.
She didn't make a 50 on it, but
55 on it. And it brought my grade up 41.
that's what I'm telling you. It's a whole lot better than a 0. Okay? Zeros kill your average. Pull your grade up. Make up zeros.
This quiz tomorrow, right?
Most likely, yes.
Hey, you know what I'm trying
Okay?
to do it for y'all what that quarter is.
No, I haven't. That's why if I get a chance today, I'll ask Ms. Glass because she's in there with registration on this but if it's busy like yesterday, I won't get a chance to ask her.
I think it's somewhere supposed to be in the March. Yeah, next week puts us where?
21 days till prom.
Holy.
21 days.
Ain't nobody going.
It's somewhere. See, next week puts us around the 21st, and I'm thinking the end of the quarter is the following week.
Yeah, I think you did.
That's why I'm telling you, if you have missing work, you need to have it made up by next Thursday. Because I'm thinking the end of the quarter is the following week.
Sit down.
All right, so we're moving on into a brand new topic. And the new topic for some of you will be hideous. Those of you who really like the math, I have bad news. We're going to do one math formula today, and we will not do math for roughly 4 weeks. So, other than that one math formula, it's gone. Now, the downside to that is that it's not just memorization so much, is that it's a lot of application. Some parts of it you will like. When we get to electron configurations and dot diagrams and some of that stuff next week, most of you will like that part. The stuff we're going to do today and tomorrow is pretty hideous. Okay? I can't make it better than it is. It's just hideous. Okay? What does it say on the board? I even gave you titles today, and you still ask me what the title is? Really?
That's why I appreciate that.
What's a quant?
What is quant?
Just write it. Just write it down.
Yeah, but I heard the name. Okay, I don't know what it is.
Now. Yes.
Space.
Oh my gosh.
Now, the idea behind today and tomorrow's lecture is to lead us into where electrons are in an atom, how they're arranged, and the properties the elements are going to have, how they react, and how they bond. Okay? That's sort of the big picture of where we're going.
What does that last sentence mean? Wave particle nature of light.
Wave particle nature of light. I'm going to explain what it means. You people are big on titles. I gave you a title. Okay?
Sorry, we're organized.
Wave particle semicolon nature of light.
No.
Wave
What it's
I'm
called.
not writing it down yet, so I feel like you're an asshole and I'm just gonna wait.
No, I'm going to write under it.
Yeah, so I'm gonna wait.
No,
Okay, so you can be behind
No, so
and then yell at me to wait for you.
a definition is gonna be after that.
There is going to be a definition behind it. What?
The quantum
You
part.
see them right now.
Quantum and wave particles.
No.
Oh my gosh. Write that as the big title, and that's the small title.
Oh, that's the small title.
It's a subtitle.
Okay.
Y'all can write it down. And we have about it.
Yeah.
Maybe this is just purgatory.
That's big. We're all doing so right.
Yeah, I was serious. I'm not making that up. You gotta have to smile all blonde.
That's what they do.
Now, if we look at what I wrote up here, all right, we're going to talk about how electrons moved from a theory a long time ago into modern quantum theory, okay? Now, they cut out the vast majority of the history of the atom and what you used to have to know probably 5-6 years ago. But they added in a bunch of other crap that, in my personal opinion, you don't need to know. However, there's a chance you can see it on the exam, so I'm not skipping it. even though I hate teaching it, and you're going to think it's hideous, because it is hideous. Now, the title is called Wave Particle Nature of Light. Sometimes people call it the dual wave particle nature of light if you want to insert that word. It doesn't matter if you put the word there or not, okay? Now, at one time, scientists believed that electrons behaved as particles. Now, you can think of that as generally as matter, okay? Now, if you think back to the beginning of the semester, we talked about that as having mass and volume, okay? Just as a quick review. All right, so when we talk about scientists saying that electrons behaved as particles, they had mass and they had volume. That's the way scientists viewed electrons at one time, okay? Now, at the same time, they also thought that light behaved as waves. Okay? Now, waves are, generally speaking, energy. Now, is energy matter?
No.
No. Okay? That's not matter. Meaning it has no mass and no volume. All right? So, the old theory about electrons is that electrons behave as particles. They have a mass, they have a volume. Light behaves as waves. It's energy. Has no mass, has no volume. Everybody okay with the theory of what electrons and light are?
So, question.
Yep.
Is there like a twist to this?
Yes, I'm getting ready to talk about what is discovered.
Okay, that's why I said.
Yes.
So this was like
This was,
before everything.
yes. I'm getting ready to talk about what was discovered.
Oh.
They discovered. I could have said once upon a time, but I didn't want to sound like a fairy tale. All right. They discovered, I'm going to change the setting on this so it's a little larger for Caleb, so I can keep it on the same page. All right. They discovered that electrons can behave as both particles and waves.
Read it out loud again.
They discovered that electrons can behave as both particles and waves. Now, if electrons can behave as particles and waves, what do you suppose that led them to the discovery of? What about light?
Electrons are too.
It can do the same thing, okay? So, light must also be able to behave as a particle and a wave.
Wait, what do you mean also be able?
So, we just said that light can only behave as energy in the old theory.
Okay.
So now we're saying the light, like the light from these light bulbs, can behave
as matter. It can have a mass and a volume according to new theory. We're not even to the fun stuff yet.
Okay, just one big theory, or like why'd you break it up in colors?
I'm just pointing out the new pieces that were added.
It's like they believe this, discovered this, therefore vice versa.
We're not even to the fun stuff yet, people. Stop complaining. Just write it down. You're going to be really confused before this by next Tuesday.
Miss Walls, what's that?
What?
Rip the Band-Aid, like.
I'm just telling you. You're just going to have to grit and bear it. All right. So basically, scientists are saying that electrons and waves can both behave as particles and waves. Whoops, I've changed the word. Let me fix that. Electrons and light. Let me change that. I know you're writing in ink, that just upset you. Electrons and light can behave as both particles and waves. Okay? That's the summary of what we just said. Okay? Do I have whiteout? I only have the tape kind.
You can't use that. You can't use your tape kind.
I used it for Raquel. I can let Ms. Bowers use it for you. You caught it.
I was scared.
That's a long walk from there to there.
It is. So electrons. Okay, you wait for my white out. So look.
Yes, you need.
I know the paper looks ugly now.
It does.
The one day I didn't bring my white out. It's okay.
It's okay.
I listened before.
It's one word.
And like,
I know, but it's a little scratch.
It's one scratch.
It's ugly.
There will be others, people.
now when we say that on our lab report, when we start scratching out stuff,
You're like, it's just one.
Yeah.
Yeah, don't be surprised when I take points off.
Yeah,
All right.
surprising to take up the tongue.
Yeah. Tell somebody who cares. All right, everybody there? Now, because electrons can behave as waves and particles, we need to know some things about waves. How many of y'all remember things about wavelength, frequency, stuff like that from middle school? I got one hand.
I'm learning that in multimedia web pages on.
Really?
Yes.
Wavelength?
I don't know why.
Frequency?
You can ask your friend Miss Pendergrass.
It's part of it.
It's part of the curriculum.
That is fabulous.
It's part of it. It's on the final.
Good for them.
So I got two hands back there.
Oh, I know.
Why aren't your hands up if y'all learned that with Miss Pendergrass?
I'm not learning anything in there.
You watch the language over there. I already have one in fourth grade who swears liberally. All right?
I was just telling her to
Who's made in the
I got you. I heard it the first 3 times you said it. I'm not deaf.
said it once.
No, you didn't. You just don't know how many times you said it. Now, electromagnetic radiation. All right? You can abbreviate this EMR if you would like, simply because we're going to write it many times. All right?
Hydromagnetic, electromagnetic,
What?
grease lightning.
Purgatory, I'm telling you.
That was funny. That was a good one.
All right, it's a form of energy that travels through space.
It's a form on or of.
Oh, of. I thought I wrote of.
I just want to make sure before I wrote it.
It's a form of energy that travels through space.
Electromagnetic. It's grease lightning.
Let me say this before y'all don't like my grammar. With wave-like behavior. Now, I feel confident.
No.
Yes, I do. I feel confident that you guys can give me examples
Let me lower it.
of EMR. Don't lower my expectations. I feel, yes! Yes! Okay, I'm pretty sure the next slide is for example. So I write it down in a minute. UV light is one.
Infrared.
Infrared.
Black light.
Microwave.
What about a black light?
I won't say no to that, but it's not on the spectrum that we're going to use.
Radio waves?
Radio waves?
Gamma rays.
Yes?
X-ray.
Yes.
Yes.
See, I told you I felt confident y'all know these.
We still don't know what these things mean. We just know their name.
All right, you can agree.
It's a form of
What
energy.
about a toaster?
So what about a toast? Heat.
I don't know.
That's like
I was like, it's
X-ray.
I kind of remember this.
All right, everybody there?
What about like a CT scan?
It's going to fall in one of those ranges. Everybody there?
Yeah.
All right. So y'all said X-rays,
Yeah.
UV, which is ultraviolet for any of you who might not have known what that was.
violet. Oh my God.
Ultraviolet.
Not even.
Infrared is abbreviated IR. All right, you said gamma.
You were excited.
You said radio. You said microwaves.
Is ultraviolet rays or light? UV light?
Yeah, it's like
Why do you think I'm wearing this?
You want to impress me? Yeah, right.
Is that all?
I think that's all I can remember you said.
Okay, I'll keep it 6 because I gotta keep this set up.
I need one more.
I'm not writing.
Now, none of these we can see. We cannot see a radio wave. We can't see 1 or 2 jams coming through the air. We can't. Really?
That supersonic vision.
Okay.
Cosmic
Can't see UVA or UVB. We could. All of us stupid white people who lay out on the beach in the summer would not get skin cancer.
Hey, Miss White, well,
Yeah.
what kind of music do you listen to? Miss White?
I'm pretty eclectic. More pop.
Why'd you
anyway.
say country? My bad.
All right.
Okay, your kids go to West. Connected dots.
Ian won't listen to country at all. He calls it goat yodeling country.
I like singing with you. I got something.
Oh my God. No.
She's over there.
Gamma, of course, is going to be more nuclear. It's going to be a little more harmful. Radio waves.
Cosmic rays are up there. What's that?
Cosmic rays. Where are you at with cosmic?
Cosmic rays.
Oh, okay. Yeah, that's going to be more in outer space. So which one up there is one we can see? Since you can see that.
It's infrared.
What? Can't see UV.
It's in between the two. It's in between infrared and UV.
So which one can we see?
Infrared.
No, it's not.
Can't see our.
Continuous.
It's on this little sheet right here.
It says what?
I'll take your man.
It's on there. It says
It does.
it says continuous spectrum.
The continuous spectrum is all of it.
Well, this one.
Okay. It says visible. It's called visible light.
I just said
We need that.
Okay. The one we can see is visible light.
What about non-visible?
I gotta pee again.
All of the others are non-visible. Okay. Okay. That's the only one that we can see. So for those of you who can see up here, and there's not many of you, all right, but all of this is black. All right, this tiny little space where my finger is the only range we can see it. All of the rest of that black line is the rest of the spectrum. We can't see anything in that range. That narrow little window is all our eyes can see. Now they spread it out to show the colors of the spectrum, and we'll talk about that in a little while. All right, but that little range where my finger is what we can see.
So wait,
The rest of it's microwave, UV, IR, visible, and
what would the
radio.
other ones look like if you could see them?
No idea. We can't see them.
Okay, but like this.
You just want me to make up something we don't know? We can't see it. No. All right. So how do we tell the difference between a microwave and a UV or a gamma ray or a radio wave. The wavelength and what else? And the frequency.
Yeah.
All right. So all of the different types have a different wavelength and a different frequency.
Isn't it,
Now, for those of you who had Miss Pendergrass's class or are taking it currently, maybe you talked about amplitude. We're not going to talk about amplitude. If you were in physical science, we would, but it's not part of our curriculum either, so we're not going to talk about amplitude. If we were talking about amplitude in physical science, we talk about loudness. How loud we are is a factor of amplitude, but it's not something we're going to work on here because we don't have to.
Isn't it like shorter the wavelength, the higher?
do we need
Yes.
to,
And that would also be higher pitch.
hey, do we need to?
If you're
space
familiar with
between
pitch.
those?
No, I'm going to do it on a separate board.
Are we gonna learn
Science
about all that stuff about like reflection and stuff?
No, I do all that in physical science. It's not part of our curriculum.
You know what? All the fun things that I actually know we're not gonna learn about.
That's all in physical science. Reflection, refraction, diffraction, interference is all in physical science.
That's like that was the fun stuff.
They signed me up for that next year. I was like,
They checked out my science book. I was like, oh, thank God.
All right. Now, you do not need to draw this chart by any stretch. All right. I'm just write what is the electromagnetic spectrum so you know what it is. Now, on the back of your orange chart, if you pull that out real quick. All right. The whole back page of your orange chart, we're going to learn to read today and tomorrow. All right. The Bohr model we'll do most likely tomorrow. Might get to it late today, but I doubt it. All right. And then the electromagnetic spectrum is at the bottom. Okay. So what is the electromagnetic spectrum?
call it EMR, because
We don't know.
trying to see Grease Lightning.
All right. The electromagnetic spectrum.
Do it right there.
Yeah, you need to know what it is. All right. It shows all types of EMR based on what? Yes. Okay. Some spectrums will show both wavelength and frequency. Ours only shows wavelength because you guys are required to know the relationship between wavelength and frequency, which we're going to learn today. Okay? And because you have to know the relationship between wavelength and frequency, they have not put frequency on our chart because you have to make that translation from wavelength to frequency on the chart. Now, those of you who've had Miss Pendergrass's class probably already know it.
What?
What's the relationship between wavelength and frequency?
I didn't say she was a good teacher. I just said.
What affects the length of it?
It doesn't like
Well, I just know she.
No, height can be amplitude.
The crest and trough.
Okay, at least you know the parts. Okay. I'll ask you again in a minute. Hold up. All
That's all.
right, so when you look at this, some of the types, you'll notice overlay. All right, so when you look at microwaves and radio, all right, a microwave is actually a type of what?
Radio.
It's a type of radio wave. All right, the only range that we can see in is right here. This narrow little band is what I was talking about. This is the range we see in. Now, they've expanded it at the bottom to show you the colors that you see, and we often call those Roy G. Biv, for those of you who don't know that. All right?
That sounds
like a rainbow.
Yeah. Red, orange, yellow.
That's so you can learn the order of the colors in the rainbow. And I'll talk about that again later. It's in another slide. All right? Now, again, because it points short wavelength, long wavelength, if I said which color has the longest wavelength is pointing this way, which color would be the longest wavelength? Red. Everybody okay with how to read the chart? All right, moving on.
Is that the amount of particles in it?
Can
Huh?
we put that?
No. Can you what? Can you do what? No, Asia.
Can we do that? When we learn the 2D, can we do that on ours? Or no?
I guess. I don't think it'll help you a whole lot, but if you want to, I guess. Can't write Roy G. Biv up there, though. All right, wavelength. What's a wavelength? All right. First of all, on your wavelength, when you draw this wave on your piece of paper, make sure you draw it like mine because we're going to label this. Don't draw it real tiny. All right. We're going to label crest, trough, wavelengths, frequencies, and you're going to have to be able to calculate a frequency. All right. So notice
that I have 3 humps on the top and 3 humps on the bottom. So if you want to be able to calculate frequency, yours needs to be drawn the same way. Now, I am. Wavelength is the distance between 2 corresponding points on adjacent
Okay, you just gotta
waves.
put distance between 2 top points.
Right. 2 peak areas.
Distance between 2 corresponding points on adjacent waves.
That's.
I wrote use
Right.
adjacent. Now I gotta figure out what adjacent is.
Aren't y'all in a math class?
To
I mean, we know what it means.
I barely pass that.
You can't try to turn a decimal to a fraction.
Neither can I.
See, about that.
Y'all did not form math.
We didn't, but we
I
barely
will.
passed.
Not yet. Not yet. We cheated our way through.
Now that I would believe.
This is 2 points.
Well, it's you.
I didn't cheat, not once.
I'm glad to hear it.
Oh, she lied straight through the
5 times.
All right, so
Wait, let me draw.
Annabelle used the words crest and trough. So what's a crest? It's the highest point on the wave. So for anybody who doesn't remember, that the crest is the highest point. All right, we've got that one. The trough, the TROUGH, is the lowest point. Are we okay with that? The crest and the trough. Not a tro either, it's called a trough. It's an F sound. Now, I said the distance between 2 corresponding points. Some teachers will tell you it's the distance between 2 crests or the distance between 2 troughs. All right, you can use that definition, but it's not just that, okay? Because adjacent means what in math class? Side by side, okay? So if we take this crest to this crest, these waves are side by side, so they're adjacent, and it's a crest to a corresponding crest. This would be 1 wavelength. But does it have to be a crest to a crest? No. If you wanted to say this wave to this wave is adjacent to this wave. 1 trough to this trough would be 1 wavelength.
So just don't go diagonal.
You can, but it has to be a corresponding point. So let's say you said going down on this wave. You would have to pick the next wave, but you'd have to be going where? Down. So going down on that wave, that would be
I'm talking.
1
don't
wavelength.
Go from a crest to a trough. That ain't
That's correct. You could not go from a crest to a trough because a crest to a trough would not be a corresponding point.
Because I can't go from the crest to the trough.
You cannot go from a crest to a trough because a crest to a trough is not corresponding. It has to be a crest to a crest or a trough to a trough. That's what I mean by corresponding points. It has to be the same point. Okay? Everybody with me on corresponding points? Okay?
This is just like bringing back.
All right. Everybody good on that? All right. Whoops. I need some more stuff.
I think I
Do it.
All right. So we need a unit because this is going to go with our 1 calculation. All right. The unit we're going to use is going to be meter and nanometer. We're going to learn a new unit today. We're going to use meter and nanometer.
Can we use them interchangeably?
It's going to be given to you in nanometers, and you're going to have to change it back to meters.
Oh my God.
Same thing.
So it's not.
Okay, it's going to be given to you in nanometers, and you're going to change it to meters.
What time do we leave?
Same time as always, 11:40.
You said meters?
Okay, yep. And its symbol in the equation is going to be lambda. It's a Greek letter, lambda, and it's an upside down Y. Lambda. Sound like one of those famous actors who might make
What is
kids
that?
something stupid.
So do you have to draw it exactly like that? Because I don't draw my Y's like that. Can I just draw an upside down Y, or do I have to draw it like that, like a stick?
It's an upside down Y. It's a stick.
Okay.
Do you curve your Y?
Yeah, I curve my Y.
Well, I tried to sit like in college and now I'm studying here. And,
Well, I guess you can just be stuck there third and fourth period. All right, everybody good?
yeah.
All right, frequency. Frequency is the number of waves that pass a given point in a given amount of time. Okay, the number of waves that pass a given point in a given amount of time. I hope you can get out of that desk.
What?
I said, I hope you can get out of that desk.
Well, you know, are you trying to move? No, I can't. This foot. My foot's too big and it can't fit through the hole. So, because the boat.
Then turn sideways and back out and then it's close.
Turn. Give me out the tile. You help me.
She sounds like a pig.
Yeah.
There you go. All right, so when we want to find frequency, frequency is the number of waves over the time. Now, what makes up a wave?
Trough and
The trough and the what?
the crest.
Okay, so that would be one wave.
Not.
It's not.
It's like Friday.
It's just not.
Well, it felt like Friday's like I do.
So,
Yeah.
when we want to count our waves, you have to make sure that you have the same number of crests as troughs. Otherwise, you have half numbers of waves.
Wait, how was that a wave?
Because it's a crest and a trough. That's one wave. Okay? So, I'm going to make life easy on us. I'm going to say we have 1 second for our time. Because I'm lazy. Okay? Time's going to be 1 second. What can you tell me about my numbers of crests?
You have 1, 2, 3.
How many troughs do I have?
3.
Okay, as long as my crests and my troughs match, counting waves is easy.
You have 3 waves.
I have 1, 2, 3 waves. Okay? As long as they match, it's a breeze. I have 3 waves. Over my time, that's why I told you I was cheating. My time is 1 second. Okay? So, my number of waves over my time gives me a frequency of 3. So, what is my unit?
Waves over seconds.
Now, we can do meters over seconds. However, we like to give it a new unit. Physics teachers do. I could care less. All right? The unit for frequency is a hertz. So, we write 3
HZ.
HZ. Okay, 3 hertz. Now, the symbol we're going to use, because we're almost to the point we're going to talk about the equation, is a Greek letter, which is nu, and U, it's an italicized V. Now, I cannot italicize a V on the board, so it just looks like a V. Now, when I type something, it will be italicized, okay? But I cannot italicize anything.
So if we just put V.
Just put V. It will be italicized when it's typed.
Slanted.
Right.
Right. Y'all see the sweet frog sign got put up? That's Johnny lit. We're doing sweet frog at Chick-fil-A. We're, here's the cookout, it sells barbecue, and y'all know how much it is, but hurts with their barbecue.
All right, everybody caught up? Everybody caught up? Fabulous. All right. How are frequency and wavelength related? So back to my pentagraph people who said they've done this. How are frequency and wavelength related?
I couldn't not say she's a good teacher.
She didn't teach us all that.
We just knew the parts.
Yeah, honestly. They just knew what you, thank you for teaching us.
Because I'm sure it's gonna be our exam.
All right, let me go here. Write the question, and then I'll draw a picture and see if you can tell me.
All right, so.
All right, write the question, and then I'm going to draw a picture and see if you can tell me.
Isn't it what Madison said earlier?
No, you can't use the turn page. You're not going to be able to. It's fabulous. That's a good looking note.
Shorter the wavelength, the higher the frequency.
Is it what I said? It's what I said.
Good job. You're smart. She did.
What?
Oh my God.
I love that sound. Yeah, okay. Oh, yeah.
It's okay.
Well, probably for you.
What's your apartment?
The box or something.
If they could haul me away before fourth period, that'd be fabulous.
Do you really like it?
No, compared to the fourth period I had last semester, they're fabulous.
Isn't the Nori in your fourth period?
Yep.
Do you hate your fourth period?
Nope.
You sure about
Last semester, I hated fourth period. I would have gladly gone with the cops
Who
anywhere
was in it?
last semester. I won't say, but it was bad.
You should look it up. Tell us.
It was just bad.
I'll look it up. Oh, how you gonna look it
I would have gone almost anywhere last semester, fourth period.
up?
I'd have gone to jail and stayed for a week.
That's crazy.
If I can find y'all.
The top of the top.
I was about to say, because you mentioned that earlier.
I was waiting pictures.
You know what?
They give a lead in the yearbook field, nothing else.
Oh, my
All right.
Great.
Here's two different waves. Okay?
I think I draw it like you.
Do we have to draw that?
It's up to you.
So the top one has.
So where do we draw that?
Higher frequency.
Hopefully with that question.
Okay.
So what can you tell me about the wavelength up top?
It's short. Higher
Okay.
frequency.
So,
This one is a.
all right, so this has a short. All right, so we have a short wavelength. So what does that mean about its frequency? How many waves do I have?
Maybe a high frequency.
Y'all can't count the waves?
Wait, that's a lot.
Okay, so it's more than that one, right?
Yeah.
So I have a high frequency. All right, so what happened in this one? What can you tell me about its wavelength?
Big wave.
Okay, so I have a long wavelength.
And
And a low.
low frequency.
Oh my gosh, I'm using red and green.
I have a long wavelength, and I have a low frequency.
Serious.
All right, so what can you tell me about how they're related? They're what? They're, I heard it back there.
Opposite.
They're opposites. All right, so they're opposites of each other. So in math class, they have a name. What's the name in math class?
For what?
Opposites.
Two.
It's like a.
I don't want to use it reciprocal. Use the other word.
It's like.
Starts with an I.
Yeah.
They're inverses. All right, so does everybody have the picture if they want it? Or do I need to wait?
I'll tell you this right now. Lexington Senior High School needs a better math field.
Yes.
Yes.
I mean, Mr. Stern is not that bad.
Would y'all stop? All right,
I had this started, but I had to fight for it.
all right, does everybody have what they want?
I read it in this class.
All right, so how are they related? They're what? They're
They're inverses.
inversely proportional.
You really had to put the paper in there.
Yep, I do. Because you might see it soon.
Hopefully not tomorrow.
Oh, wait, we have a quiz.
Well, I can't make any promises like that. So what does inversely proportional mean?
Opposite. Well, if we
If one increases, the other decreases.
So,
Will it be multiple choice tomorrow?
Yes.
No.
is it gonna be like, you give us a wave, and then we gotta label everything, and then we gotta see how many wavelengths? That'd be good.
No.
Oh, it's not as easy
What
as
is
counting.
it?
I might say something like, what is wavelength? Or what is
How long
frequency?
the wave is.
Or what
Actually,
unit?
make me
Or calculate the wavelength, or calculate the frequency.
Okay, calculate.
Or
We're
what
about to
color
learn
of
that,
light
right?
is this?
What?
We're not there yet. We're getting there. We're
Okay, I was
almost
like, we
there.
have not learned that.
We're almost there.
By the way, what is the quantity?
That's why, that's why I don't have to write stuff every day.
Yes. All right, so what is the equation that we're getting ready to learn?
I don't know.
All right, so the equation that we're getting ready to do is C equals lambda nu. Now,
That word.
I showed, so we just talked about it. This was frequency. This was wavelength. Shush back there. C is the speed of light.
Really fast.
Yeah, really fast. That's a good one. Now, the speed of light is a constant, meaning it's not going to change. So C is equal to 3.00 times 10 to the 8th meters over seconds. That's a lot. That is 300 million if you want to know how fast the speed of light
Is
is.
that on our orange sheet?
Meters, no, it's not. You got to memorize it per second. So, you remember meter sticks? Remember seeing a meter stick?
No.
3
I don't
feet.
have one out. All right?
It's 3 feet, right?
It's a little longer than 3 feet.
More.
You're thinking about
What
yards.
was the equation for?
We're getting ready to calculate wavelength and frequency. Yeah.
Why do you
meters
calculate
over
if you
seconds.
just the wave fast? Am I right? I don't know, oh my god.
But what if they don't match?
So you're talking about one of these, 300 million of those in 1 second. That's how fast light moves. 300 million of these in 1 second. Okay?
I just think that we can move that.
Yeah.
We be to school today.
All right. Everybody got it?
Wait.
You're taking quite long.
Wait, that's
Oh,
to
yeah.
the
M over S.
M over S.
That's the unit, M over S.
So we need to memorize that C equals.
Meters over seconds.
Hold on. We need to memorize that C equals 3.5.
You need to memorize the equation and the speed of light. Neither of those things are on your reference table. None of this is on there. I will tell you now, this is one of the units that we go well over what is on the state test.
Why?
Because you're in an honors class.
Because we're honors.
I don't want to be in an honors class. Can they have a regular chemistry?
Wait, why should they know that?
They do.
One box. Decrease.
I thought they did.
A lot of this, no.
Is there a
Part of this,
non-chemistry
yes.
honors? Is there a chemistry non-honors?
You had to make a choice, physical science or chemistry. If you went physical science, you went non-honors. If you went chemistry, you went honors.
I don't
Really?
think this is fair.
Yes.
Physical
Wow.
science
How's
isn't.
Say what?
How's that fair?
How is it fair?
So we're forced to learn significant.
You're going to take a physical science.
Miss Wall, you know what I thought about? You teach every student that has graduated from here.
No, I don't.
Yes, you do.
You could have had Mr. Moore.
Okay,
Miss Wall.
Mr.
Oh,
Moore.
yeah.
He teaches physical science.
the
Too.
old white dude.
The old white dude. Yeah. the-
Okay.
I've never spoken to him.
Before he came.
Huh?
Before he
I know
came.
about-
Mr. Dr. Phillips told someone. There was a time when I did teach everybody, but we changed that when we got rid of state testing.
I was talking to my grandpa and my mom, and I was like, I just said your name, no bad things. But my mom said your maiden name, and this my grandpa was like, oh my gosh, she is such a good teacher. You're so lucky. This whole Slater or something?
Yeah. All right. So write this problem down. This is the only math problem we're gonna do.
That's an Evans Walk. She had this whole Slater.
Done a long time. Well, 2 years over time.
Thank you.
Now, this is the only math problem we will do for roughly 4 weeks.
How do we know what color it is?
We're gonna learn that.
Why?
We're gonna have to identify the colors, but
Oh, yay.
Oh, dear God.
That is if we ever get through asking me questions before we learn how to do it.
how can we have
Miss Wall is tired of us.
40s.
We're
It's
not
always
even
an
done
eight
with our
and
first
four.
quarter review.
I know.
And you're always tired of us.
Wait, who's older? You or
Miss Wall loves them.
Miss Wall, I have a question.
Really shocking. Y'all, question?
Never.
What's the question?
What are benchmarks?
Winter benchmarks?
Oh, yeah.
I have no idea.
Why you don't have one?
If they don't tell me that I have to give one, I'm gonna conveniently forget.
Me
Same.
too. I think you should.
I won't remind you. Definitely could be even if they were.
I mean, I have one, we could easily do it. but-
No, stop.
If we can take the benchmark, we'll take grades again.
That's great.
Yeah, no.
I don't.
You should
Benchmarks are not grades for me that I just, whoops, count, I count them.
And what if you count for the second quarter?
Don't know, I'd have to figure it out.
At least we're better than your fourth grade from last semester.
That is very true.
Were they
You
physical
wouldn't have to
science?
be that good to be better than my fourth period class. That
How's your third period? They seem really quiet.
was pretty good.
Cause like when I come in there, they are silent. Other
They
than
are
that
not
emo
quiet.
kid that sits right there with like 7 lip piercings.
Oh, Trevor. Talk about that.
Trevor, he's
Yeah.
okay.
He's always yelling about something.
Alright, so, how do we find frequency?
It's C equals lambda.
C equals lambda nu, alright? So we're using C equals lambda nu, that's our formula. Now, well, you better remember it. Alright, so from there, here's our problem. Alright, we know the speed of light is 3.00 times 10 to the 8th meters over seconds. Okay, that's the unit, right? Look at this unit. What is it?
Nanometers.
It's nanometers.
You didn't convert that to meters.
You can't plug that in because it's in the wrong unit. Okay?
I don't like
We're looking for the V, but we can't put it in for our wavelength because that's in the wrong unit. So we have to change it to the correct unit before we can put it in right there.
Do we have a chart to do?
Yes, we do.
Oh my goodness.
I think so. If we're balancing, I'm walking out of this classroom right now.
We are not balancing. So we're going to take 450 nanometers, and we're going to go nanometers to meters.
Oh.
The problem is, y'all don't know how to change nanometers to meters.
We'll find
Yeah,
out.
only do this when it's nanometers. Okay.
Will we ever have
Okay.
to change from meters to nanometers?
Nope.
So basically, things that start with M get a 1.
Pretty much. We have to memorize that
Actually,
too.
we got the mole ratio.
You're not saying these out loud.
Really?
I was like super intrigued too.
It says he's
Okay.
on me today.
So, in the box, as someone pointed out, we got to memorize that too, don't we? Yes, you do. All right, you have to be able to change meters to nanometers. You don't know how to change meters to nanometers, so that's how you change meters to nanometers.
So,
The biggest unit still gets a what?
a 1.
A 1. So I put a 1 next to meters. Meters is bigger.
Nano is the study of small things,
Hey.
nanoscience, all right?
Um,
So nano is very small, hold on. So nano is 1 times 10 to the 9th. So we're gonna put 1 times 10 to the 9th with nano. You have to learn that that is what that number is. It doesn't fit with the King Henry died, so I can't give you some catchy name for that. So you're gonna put 1 times 10 to the 9th with nano, okay?
so
And now you're gonna divide and get your answer for meters.
It's
Now, Annabelle.
4.5.
1 times 10 to the 9th is the Avogadros of quantum.
Okay, if you wanna think of it that way, sure.
Yeah, and so like, do we need to do second E2?
Yes.
Oh my god.
What'd you get?
4.5 times 10 to the negative 7.
All right, so we get 4.5 times 10 to the negative 7th meters. Now, this is our wavelength. Okay, that's what you just found, is wavelength. So now, we're going to stick it in our equation for our wavelength. So 4.5 times 10 to the negative 7. Now, if we want to find V, which is frequency, what do we do to find the frequency?
Divide by 4.5 times 10 to the negative 7.
Exactly.
She was ready.
So 4.5 times 10 to the negative 7th on this side. 4.5 times 10 to the negative 7th on this side.
Really tired of this already. You need to get some-
Don't care.
Wow.
So what do we get?
so silly.
Wait,
Wait, why'd you mark out 10 to the 8th?
I didn't mean to. You're right. I meant to mark out just that side.
Yeah, be confused.
Error.
That's Ms. Wall's dumb error.
It's 6 point, lots of sixes. E14.
6.67 times 10 to the 14th
Okay.
hertz. How do we do what? So you said 3.0 times 10 to the 8th. So 3.0 second EE8
Okay.
divide 4.5 second EE negative 7 equals.
I got error syntax.
Okay.
What you doing wrong, Rosanda?
See?
Make sure you include parentheses.
No, you're not saying second EE negative 7.
Oh, you sure?
Yeah, you already said it's of course.
Oh, well, it was negative, so.
It's negative 7. No parentheses.
Whoa.
What? What? What's wrong with it? Maybe she's just higher.
Nalasia.
Oh, you.
Yeah, I'm kind of funny.
You're alive. You look.
You should have that on video.
She literally came up cross-eyed.
That was pretty funny. You okay over there? They're worried about you.
No, Nalasia was worried about it. Not Nalasia, Annabelle was
I was
worried.
worried about
The rest of you just figured you needed a nap.
Yeah.
All right. Oops, back to color. All right, so we need to find the color, right?
Oh.
Now, what's our wavelength?
Not sure.
4.5 times 10 to the negative 7.
All right, you got your orange chart handy?
No.
You don't have to have it right now, but this is where you would look on the quiz or if you had to find it. All right, so we would look on our orange chart. All right, here's our wavelengths right here, right? So 4.5 times 10 to the negative 7 is the number line. So 4.5 fits in right here. So what color is it? That's how you find color.
Oh,
Wait,
that is insane.
wait, so you don't find it based off the answer, you find it based off?
No, because the chart is based on wavelength and we calculate frequency.
That's all I have a question.
Yeah.
So do the numbers at the bottom, like 7 to 4, do they correlate with like the ultraviolet X-rays as well or not?
These numbers here correlate with ultraviolet. So these numbers would tell you ultraviolet. These numbers here all go with visible light.
Black lights. What gives us?
Yes, black light has to be invisible because we can see it. Yes, ma'am.
The answer to that question would have been B and blue.
Yes, there would be two answers because there were two questions.
So it would be 6.67 times 10 to the 13th.
Yes,
So if we had questions like this on quiz tomorrow, we'd have to put 2 answers.
correct.
Goodness.
It's blue. The answers on the quiz tomorrow, or this question that we just did, would be this
And blue.
and blue. Because there were 2 questions in the question. So there would be 2 answers. All right? Can you do that one?
No.
Y'all find for me the color and the frequency.
I'm not ready for it.
Why not?
No, I.
Try. Try. Instead of telling me you can't, try.
Never say you can.
Well, I might mark Dylan here so he came from guidance. I'm sure they're serving some good vittles in the cafeteria today.
Not really.
Isn't it like the
You know, we have the same thing every week on the same day. It's really weird.
Yeah.
I'm just pissed we don't have chicken nuggets anymore. Like, it honestly hurts.
And all this food is really crappy.
I don't know.
What was that ham thing that they gave y'all? the other
That
day?
was absolutely disgusting.
It was supposed to be turkey.
I didn't try it. It looked like it made me want to throw up.
That's disgusting. With what?
Say what?
Balling right now. Do that. Okay, you can virgin jets. Okay. Got the answer, boys. So. Oh gosh, and I have all the colors. Oh. That's the sound of spraying.
All right, y'all got it?
No, chill out.
Why are you doing this so fast?
We're out of the room.
Yeah, we are.
Well, I'm not in. I need time. Can I work your underwater? Let me do it. This is Paul. I did it on board. I did too.
Oh,
Go ahead.
Okay, class. They're pretty cool. What did you get? See, but the other one, the frequency.
No, that's the hurt.
She got it. And we have to know what color it is.
I assume she's going back.
Might be messy.
I'll get a shot of water.
Huh?
I'll get a shower.
Shock.
Go Don't spike it with anything while you're out there.
Hey,
Hi.
It's still red. You just pushed too hard on it.
I thought it was orange.
Give her 1 extra credit.
Okay, maybe it's orange.
Miss Margaret said if we bring her old, like, makeup, what's it called?
Brush
mascara bottle. Yeah, she said she was gonna give us an extra point. Each one will bring it over.
Oh, it's because they could have.
Yeah.
Oh, so you wrote in the colors that all you do?
yeah.
Wait, I'm gonna support.
You gonna put a unit on the answer?
Wait,
you're right.
Wait, Miss Hall, how do we know which?
I think we use to find like the colors. So like we use the chart.
And what color is it?
She wrote in the color it is apparently. You're supposed to be smart enough to figure that out.
Yeah.
So we use the number. We use the answer we find from the chart to find
Use
the
the
color.
answer that's the wavelength to find the color. That's 6.25 times 10 to the
Did I
negative.
get it right? Did I get it right?
It looks red.
I don't know the actual answer.
Well, that's fine.
Extra credit.
Yeah, extra credit. If she gets it.
Doesn't work that way, so now.
It
All
can't.
right. So, did everybody get 6.25 times 10 to the negative 7th?
You did.
All right, so if you go back here, 6.25 times 10 to the negative 7th sits here, which is orange. All right? Annabelle was trying to be cute and wrote an orange because that's what color it was. That's why she didn't write orange on the board. She wants you to figure out it's orange.
Answer orange dot.
Okay? Questions about why she did it in orange. Okay? And then 3.0 times 10 to the 8th divided by your wavelength gave her that. Is that what you got when you calculated? 4.8 times 10 to the 14th. Okay. Any questions? And then hertz is the unit. Everybody good without a calculator?
Well, you got it in front of you right now.
I'm pleased. Now if you can just pass the quiz tomorrow.
Yeah, I brain it.
All right.
Is it gonna be questions like that?
Put that on to tomorrow.
Nope. All right. So now that we've learned about waves, we're going to start talking about 2 examples of how electrons behave as waves. The first one is called the photoelectric effect. We're going to talk about neon lights and the photoelectric effect. The photoelectric effect is probably the worst. Okay?
Someone's prom theme, I'm pretty sure, it's either West or Central, is like neon lights.
I think it's West.
That is, are you in the 80s? So that ain't.
I'm pretty sure Shelby told me it was that.
Okay, I would love an 80s, but not a neon lights and they better have glow tape everywhere. It's weird. Yes. 80s. I get it, 8, I put my mom's progress.
All right. So
I can fit it.
Now, what is the photoelectric effect? Now, would you write this down before you're yelling for me to wait?
Oh, sorry.
Yes, I'm aware. Now, the photoelectric effect refers to the emission of electrons from a metal when light shines on it. So, what we're talking about is having, let's say, a piece of, just so you can relate, a piece of aluminum foil. All right? And light shines down and an electron pops off. Okay? Comes off. Yes. The whole concept of the photoelectric effect from beginning to end is going to be bizarre. Okay? I cannot fix the bizarreness of this theory. Okay? It's just weird. You're going to have to hold your questions and just go with it. All right?
So they're saying it's stupid, but we should still listen.
Yes. I cannot fix that it's weird. All right? It's just one example of how electrons can behave as light. Neon lights and the photoelectric effect are 2 examples that I can give you to explain this. All right? Aluminum foil. Now, the thing photoelectric effect weird for most of us is the frequency of the light that strikes the metal. Okay? So the mystery of the photoelectric effect involves the frequency of the light. Basically, will any light that hits the metal work? Can I use the light bulbs from in here?
No, they're not neon.
Do they have to be neon?
I don't know. No. It's
No.
called neon lights. So just
Well, the neon lights will be tomorrow. We will not get to those today. All right, we're just talking about the photoelectric effect for the next few minutes, and we won't finish it today. All right,
Okay,
so
well, no, pause. On the quiz tomorrow, is it just gonna be like questions like I just did right, or and
anything up through that would be fair game.
but not this?
Maybe the definition, but that's it.
No.
Wait, so we'd have to write the definition?
You might have to write definitions tomorrow, yes.
Can we just not do it on this, cause
Yeah, because
Make it clear.
I didn't get that right.
We're all done. No, that's.
I'm tired. I really thought it was Friday. That's sad.
It's not Friday.
Yeah, we know.
As Linda found out this morning.
It's not Friday. All right, so what I'm saying in brown up there is if we put aluminum foil on the desk and these lovely fluorescent bulbs that we have in here shine down on some aluminum foil, will electrons be ejected from the aluminum foil?
We can't
You think?
see it.
I mean, based on the science classes you've had thus far, do you think electrons will be ejected from the aluminum foil?
No.
No, that's correct. No. All right, so. All right. Wave theory, as we know it today, says that it will not work. All right. Wave theory predicted light of any frequency would eject an electron. All right.
Because I have no word on paper.
And you're going to need another piece of paper. You write on your hand, your arm. It's going to eventually wash off, but.
You got those?
Purgatory.
It's purgatory for us too.
Only 2 more years to live.
Makes you feel any better.
My mom was so hurt when I told her we were retiring in 2 years. She was like, "Why can't it be 3?" Because I would take him to your sophomore year.
There's still hope. I haven't figured out if I can afford to retire yet.
I'll give you $1 for staying for your kids.
Huh?
I'll give you $1 for staying for
$1. I pay $600 a month in insurance between my kids and husband. I don't think $1 is going to do a lot for me. All right.
Oh my God.
See, we're gonna have a little talk.
Yeah, we're going to have a little talk. Right. There's only 28 slides in this one.
Oh my
God.
There's only 20 slides.
I did this one several years ago when we had to teach this crap because I was like, good Lord, I never remember all this stuff that's in the curriculum. All right, so wave theory said all types of lights would eject electrons, right? But you guys aren't scientists, and even you know this ain't going to work. So only light above a certain frequency is going to knock electrons loose. So there has to be some other way to explain it. So that's what we're going to work on next.
Why
What?
are scientists concerned about this?
Why?
Yes.
You know, that's a very good question.
Like, what do scientists even study?
Would it even change?
They study all kinds of stuff.
Like,
Would it
what's the
even
point?
change anything?
They just get bored of things. Do they just get like?
Some scientists work at universities and they're paid to work on all different types
Do
of
they
things.
just get bored and be like, oh, I wonder if some light will knock off some electrons on some aluminum foil? Like,
Do I care? I don't know what metal they use. We can look it up, but I don't
Would
care.
it even change anything?
But they're just interested. Not me. It's not my thing, but they were. All right. So
I'm not writing about it.
there's a German physicist by the name of Max Planck.
And he's dead.
He is dead. We talk about a lot of dead people. All right. He proposed that electromagnetic energy, or EMR, all right, is not released continuously, but in small packets called quanta.
Quantum theory.
Yes, that's where the name's going to come from.
That's exactly where the name's gonna come from. All right, so instead of believing that light is going to be a steady stream of particles, he's going to believe it's going to be almost like a burst of small packets. So I'm going to draw this picture a little differently this time. And I'll let you catch up before I draw. It's up to you, they're your notes. Annabelle's out of paper, so I guess she's not drawing anything.
Great.
And about, look, she has paper.
She has paper in her
It's
notebook.
not gonna be neat if I just write a sentence on that sheet.
Actually, it was more than a second.
Actually,
You have 28.
You need any more?
I have half a page.
This is my third page of notes in one day.
All right, so
George. Thanks.
if you go back to this picture I drew, all right, notice I drew it as a straight line, right? To try to show that it was continuous, all right? Now, with this picture, all right, so there's my metal. This time, okay? This time, I'm going to draw it as little tiny dots, all right? Because I'm trying to illustrate that it's not released continuously, okay? This, all right, is going to be called a quanta.
You think it wrong.
So every dot is a quantum?
Now, actually, I need to alter that. I need to change it to a quantum because I used the wrong ending. All right, quanta is plural, and I'm pointing to a singular dot. Quantum is singular. All right, and I'm going to stop with the green. All right, a quantum is a minimum amount of energy that can be lost or gained by an atom. And after we get this written down tomorrow, I will go back through all of it again. It makes more sense after you say. I told you I would only go through the definition of the photoelectric effect for quiz.
Wait, so what's on the quiz?
Somebody better help Miss Sleepyhead over there for the quiz tomorrow.
It's on the question that I did right. I don't know if you're, what are those called? What are those called? The one that I,
Finding wavelength,
finding
frequency,
color, finding wavelength, finding frequency.
All right, so the quiz is all the way through the definition of photoelectric effect. So for homework tonight.
Bro, chill out.
Girl, chill out.
We have a whole lab report.
I told you yesterday that there would be homework and a quiz. So if you waited to do the lab report tonight, that's your fault.
I was at work.
I don't care.
I didn't work.
You tried to be away.
You try to be a mom and work it.
Oh my.
You can tell your kids I can't tell my employees.
I'll be here somewhere supposed to. Sometimes 6:37 tonight, working registration.
You won. You won.
Alondra.
If it's like 15 minutes before closing,
Well, right here.
if you know we're about to close, don't come in.
Let's figure out which one there.
Please, thank you.
All right.
And then when we get here,
Who came behind the counter? I don't know who opened the door.
All right. For homework, we're doing 1 through 11. The rest of them we will do tomorrow.
No, quick question. Say you got an entrance, right? And you go behind the register, you're the entrance from the outside. And somebody come up to that entrance, like banging on the door. But you gonna let them in? My point is that. So let this man in, and he's banging on the door, screaming. And she let him in, and he start walking behind. I'm like, are you trying to die? Because I will hop right through this window, and I can't see my damn one of y'all, and be like, I don't even work at Chick-fil-A. This is Chick-fil-A. Like, y'all getting shot like 80 times.
Miss Wallace
She's
is
just
good.
stupid. Why would you do that?
I tend to
I
agree.
can't.
Miss Wallace is good.
Good.
Okay. And the calculation.
Oh.
So it's 6% composition
She
of
will.
magnesium oxide. So you put butter
You take the mass of magnesium,
divided by.
it's in here, the mass of magnesium,
Oh.
divided by the mass of the
I think you
magnesium
just have to
oxide.
read it.
It says, it said on the board. That's the answer. And
Yeah,
then you do oxidation. Send it to the next one.
you take the grams of magnesium divided by the mass of the periodic table, divided by the moles of magnesium.
All right.
Yeah.
Honestly, if you could use
That
that.
makes sense, yeah.
Oh, so you gonna have to text me whatever she just said.
No, you weren't. I was not allowed.
Okay, mother.
Yeah, sorry.